We are all stardust, we are all star stuff. This intriguing quote by the astronomer Carl Sagan basically sums up what we're all made of. The remains of violent, exploding stars, or what astronomers like to call supernovae. Supernovae mark the death of stars much more massive than our Sun, and they play a key role in shaping the universe. Their dramatic end means that they release large quantities of material into space, and from this, new stars and planets are formed. In fact, most of the elements that we find in nature were all once created and released in these powerful explosions. These elements include the oxygen that we breathe and even the calcium in our bones. Now, although supernovae are one of nature's grandest displays, we know very little about them. For example, what are the effects of an explosion to human life? Well, to understand a bit more about this, we need to realise that supernovae are very bright and release light at all different wavelengths. Now, different wavelengths can do different damage. For example, UV light can cause skin damage or even cancer, while infrared does relatively little damage. X-rays are known to cause havoc as well, but just before we panic, let's look at some numbers. So for a typical supernova to be as bright to the human eye as the Sun, it would have to occur at a distance of about a light year. Now, the nearest star to us, with the exception of the Sun, is about 4 light years away. Now, a supernova would certainly affect the life cycles of plants and animals if it were even 100,000 times fainter than the Sun. Now, since objects get dimmer as the square of their distance, this means it could be 300 times further away, or at a distance of 300 light years, before having any real effect on the Earth. Now, luckily, this is much closer than the nearest possible supernova candidate. Now, the Sun itself emits X-rays in the form of solar flares, and without the protection of the Earth's atmosphere, they could do serious damage. Now, for a supernova to emit the same amount in X-rays, it would have to be at a distance of about 5 to 60 light years away. Luckily, again, this is far closer than the nearest possible candidate. Now, gamma rays can also be dangerous to us, and the effects of these are unclear. But it is worth remembering that the Earth's atmosphere protects us very well against radiation from space. So to sum up, a supernova would need to be very close, certainly much closer than the nearest possible candidate, before doing Hollywood movie type damage to us all.